So the basic wiring, that's pretty simple, and then there's some supplemental wiring for some lighting. You can see that there was a light up there that's broken. So there's lights in the front here. They're not broken, so they might still work if wired up. And then, alright, so that comes in right here. There's the lighting wiring here. And then, looks like that's going over to, alright, so this is the light switch. This button right here is fused. It's coming off the light switch, so that's probably what's picking up its 12 volts, and then it's sending probably 12 volts down this green wire when it's pushed. And if I were a betting man, I'd say it goes to that horn. That's exactly where it goes to. It goes to this horn. So that's interesting. So we can dispense with that. So we really got two wiring harnesses that are coming up from down below the engine side, or whatever you want to call it. You got this one over here that's going to the current key switch that I've been jumping out. And then you got this other one on the other side here, which is going up to the ammeter. So this is probably the one that's going over to the alternator and voltage regulator circuit. Alright, so here's the alternator, and then we got a voltage regulator sitting here that's completely disconnected. So it looks like there was originally a generator on here with a voltage regulator, and then they just, well, what did they do here? Why is that disconnected? That doesn't make sense. Well, there's a diagram, says charging circuit wiring diagram for tractors with alternators, that I have in the Oliver manual that came with the tractor, but that's not going to be much good for me because you'll notice this has 4 connections on the regulator. I think I only saw 3 connections on the one that I have down there. To make matters worse, got some weird stuff going on here. If you follow this wire over right here, this wire goes over through the ammeter up here, feeds these 2 gauges, which is a temp gauge and a fuel gauge, which oddly enough the temp gauge is an electrical on this unit. But anyways, and then it just goes up here, comes back over to terminal A on the key switch, but then that also has a wire that comes down here and comes right back to here. Now, an ammeter, when it's in its circuit, actually passes all the current, so it actually acts almost like a short. It shouldn't affect the circuit. So if you imagine this being closed, like a switch that's closed, what you've got here is a big short circuit. Doesn't make sense, except for the fact that they've got an arrow pointing to this wire that's running from here to here, and they're calling this the brown and white resistance wire. So that almost makes it sound like that's a special wire that actually is going to have resistance built into it, which I'm not familiar with that concept. So I don't like this diagram. Alright, so this type of alternator has its own regulator inside of it. And what you've got is you've got 3 wires coming off this alternator. And if you notice, there's only 2 here, but it's actually a 3-wire alternator. What you've got is you've got the field wire that actually comes over to, I believe this is the field wire, comes over to this terminal here. This big terminal right here is the B terminal, which is the battery terminal. So this is your voltage coming out and goes over to the battery. This wire normally, I believe this is the sensing wire. So what they're doing here is they're running this right over to the battery terminal. So that'll work. The only drawback to that system is typically the alternator won't start charging until you get up to high RPMs. So the question is, don't know if it's going to work in this application. Don't know if they have actually had this alternator working. For all I know, they threw this alternator on here and never was able to get it to work right. The wiring's all in shambles anyways. So anyways, that, and then this white wire here goes over. Typically this white wire would go over to what they call your idiot light, and then the other side of the light would go over to the run terminal on the key switch, and then basically that's the light that comes on when you turn the key on and then when the alternator starts charging, the voltage on one side of the light comes up, and since it's already the other side of the light's tied to the run or battery side, it balances out and the light goes out. Hope I didn't confuse anybody with that, but the important thing to realize is that this white wire typically goes over to your charge light. Okay, I couldn't figure out why I couldn't find this big red wire coming over underneath the dashboard, and this is why I cut back on this electrical tape, and you can see right here, looks like they're using the original wiring loom that went over to the voltage regulator here, and they disconnected it, cut the wires, and they spliced in the alternator here. So I've got a red wire that's going to be going back there somewhere, that's going to be this idiot light wire, and then I've got this yellow, looks like it's yellow wire, going to be the battery wire. Let's see if I can't find those. Alright, so those are coming in over here through a grommet, and here they are. Here's the 3 wires. I've got the red wire which goes over to that, now goes over to the idiot light wire. I've got the yellow wire which is now my battery wire, and then I've got this third one here which is cut at the other end, at the alternator end, so I don't have to worry about that. And then that goes back into tape here, and that looks like that's going to go up. Okay, so that's, there we go. So that's, alright, so that's this loom right here. So we've got, this is the red wire. It's not going anywhere right now. And then this is the, this must have been the yellow. And then where's that? Oh, here it is. Oh, just lost the... Alright, this is the bracket that holds up the meter here that's completely broken. Looks like somebody took the bracket off because they were going to take that gauge out, and then it looks like they just said the hell with it and gave up. Must be stuck in there or something. Not going to worry about that now. So what I want to do is I want to verify that these wires are going where I think they should go. Look at that big burn mark on the wire right there. You think that arced out? Yeah, so that probably hit the case at some point. So let's see if these wires go where I think they go. Oh, hold on here. We got a 4th wire in there. Look at that. Uh-oh. Where'd that wire come from? Why is there 4 wires? Alright, go back to the other side, see if I can't figure that out. Well, I only see 3 here. I only see 3 there. And I only see 3 there. Where's that 4th wire coming from? Ha ha ha. That's weird. 3 wires coming out of the loom right here. Oh, hold on. There it is right there. 4th wire. It's cut. Right there. Right. Ah, shoot. Get that down there. See it right there? Right there where my finger is? That's it right there. Alright. Let's get my meter out and do some continuity checks. Okay, I've got my meter, one end hooked up to the B terminal on the alternator, and the other end I've run over there, and I've got an audible continuity feature on that meter, so I don't have to be able to see the meter, which is nice. In a case like this, all I have to do is now reach up and grab my meter lead and try and get it onto the white wire. And I don't know if you can hear that beep or not, but that tells me that that is the B terminal wire. So they got it coming right over to one side of the ammeter, which is where I would expect it to be. Okay, and I checked the continuity to the other side of the ammeter, and I've got continuity there, which I also would expect. Because again, like I was explaining earlier, the ammeter acts like a wire in a circuit. You know, it monitors the current flow, but it also lets all the current flow pass. So That's what I would expect, and then we get a wire coming off of that, coming right over to the key switch, so we're going to disconnect this key switch now. I've now removed the 2 key switches. Not one, that's right, 2 key switches that were on this when I got it. This one was the one that was on here, so I got a feeling this was the more recent one that was installed. This key switch doesn't want to turn at all. Assuming that that's the correct key that's stuffed in there, it's just probably seized up. So I can't get that one to turn at all, and I can't get the key out. This one, which was connected to some wires over there, actually mostly cut, this one actually turns. This is the type of key switch that you turn it back for accessory, and then you turn it one click over from that is the off position where you can remove the key, which I was able to do. And you click it one more time, that's the ignition on key, and then of course you push it all the way over and it's spring loaded for the start. So this is, if this switch tests okay, then I might be able to use this one. So this one's labeled clearly enough, battery, so your 12 volt from the battery comes into here. Over here, IGN for ignition. Over here, ACC for accessory, that's when you put the key in that rear position. And then right here on the top, this one right here is ST, and that's your starter. So that's when you engage it in the spring loaded position. It's going to send 12 volts there. So we can test this with my continuity meter. Okay, this switch is shot. It's not giving me the proper continuity no matter what position I put the key in any of these terminals. And furthermore, it has a high resistance continuity between starter and battery, about 2.5 million ohms, which is why when I had this hooked up before, my starter solenoid started to chatter for no apparent reason. That was because of this. So there's something foul going on inside here, and unfortunately this is not the kind of unit that I can take apart and clean the terminals and put it back together. It's a one-shot sealed unit. Well, this key switch, I forced it to turn, but it's junk. You can tell it's all corroded inside, so that one's shot.